Hello world! Welcome back to another corCTF 2024 write-up video. In this video, we'll be walking through the forensics challenge, The Conspiracy. Let's get into it. Our intelligence team created a chat app and secretly distributed it to the Lemon Thinker gang. We've given you the application source and a capture taken by one of our agents. Can you uncover their plans? Alright, so they give you a challenge.pcat file and a source.py file. I already have them open here. And we're going to take a look at the source.py script first. And as you can see here, there's a chat logs.csv being opened. And then there's messages being pulled from that chat log and being stored in this messages list variable up here. And if we scroll down, we're looping through those messages and we're encrypting each one of those messages. If we look at the encrypt function here, it's selecting a random integer from 10 to 100 as the key and then appending a key per each of the characters in the message. So the number of keys will match the number of characters in each message. And then here it's actually encrypting each character of the message with the corresponding key from the keys list. And then it's returning both the keys and the final message, or the encrypted message rather. And then it's sending a packet containing the encrypted message that it's currently indexed on. And then it's sending a second packet with the key that was used to encrypt the original message. So that being said, that should reflect in our packet capture over here. And if we scroll down in our packets, we'll start noticing these series of numbers that look like the packets that would be being sent from the source.py script over here. And as you can see, you have what looks to be the encrypted message characters. And then the following packet looks to be the keys, right? Because if you look at the values of these keys, they only range from 10 to 100. And you can keep scrolling down because there's multiple packets like this. So we need to parse this data out of this pcat file so we can then decode it with this crack.py script that I have set up over here for our convenience. So we're going to parse this data out by using tshark, which is the command line version of Wireshark. And we're going to do tac-r to specify the file, which is our challenge.pcat. Then we're going to specify the fields we want by doing tac-t fields and then tac-e. We want the TCP payload, and you can figure out what that field would be by doing right click, apply as filter selected, and we'll scroll to the beginning and you'll see that it's tcp.payload. So we'll do tcp.payload here. And if we press enter, you'll notice that we get the raw data back as hex. Now we want to redirect that output to something like an out.txt file so that we can read it into our crack script and be able to manipulate it there. But we're going to have to do some cleanup on that file. So we're going to want to take our out.txt and put it into hxd. And we're going to get rid of all these beginning bytes because we don't need those. And then we're going to scroll down to the bottom and get rid of any extra bytes down here as well. And then notice how there's null bytes in between each of our readable bytes. We don't want those, so we're going to replace all those null bytes with nothing. We'll do all, replace all. Okay. Okay. Now we should be good to go. We'll save that. And now we can actually get to coding out our crack.py script. So we're going to start off by reading in our file, our out.txt file. And then we're going to store all the lines in the file to a variable. Then we're going to loop through each line of the file. But we're going to skip every 2 indices. And you'll see why here in a second. Then we're going to store the message as lines at I, because remember each message packet comes first before the key packet, and then the key packet will start off as lines of I plus 1. Now we're not going to focus on the key right now because it's going to be kind of the same way we do the message, so I'll just be able to copy and paste it afterwards. And you'll see what I mean here in a second. From here, we know that it's in hex, right? So we're going to do bytes.fromHex to convert it to a byte string. And then we're going to .decode it to convert it to a literal string. And then we're just going to print out our current message because we want to track our progress. That way you can kind of see how this is playing out. And I didn't do with open, so let me do that. Now let's run it. As you can see, we had the decoded hex messages, and now these are not Python lists. This is actually a literal string. So we need to convert this to a list so we can perform our decryption operations on it. So the way we're going to do that is we're going to do dot strip because we don't want the brackets. And then we're going to do dot split on the comma space. And now what that gives us is a list of strings. Not quite what we want because we wanted a list of integers, but that's okay. We can correct that as we move forward. But now we're going to do this same thing with our key, but instead of I, we're going to do I plus 1, right? Because the second packet is the one that contains the key, not the first packet. And that's why we skip by 2, because we want to group the messages and the keys together and then move on to the next pair of message and key. And now we can get rid of our print message here because we don't need to test that portion of it anymore. And we're going to do for j in range of the length of the message. It doesn't matter if you do length of key or message here, it'll be the same length. And we're going to print, and this is where we're actually going to reverse the encryption process that happened in the source.py script. We know that the ordinate of the character was multiplied by the key, so what we have to do is divide the encrypted number by the key to get our original ordinate back. So the way we're going to do that is we're going to simply do message at j, floor divide, because if you don't floor divide, it's going to be a floating point decimal, and that's not what we want. Key at j. And you can't just leave it as is because remember these are strings, so we have to convert them to ints. And then we're going to want the character of that operation, right? Because this ends up being our original ordinate, and we need to convert it back to a character so that we can read the original ASCII messages that were encrypted. And then we're going to go ahead and do an end equals nothing. That way we can have it all print out at once without it having every character on separate lines, because that would be terrible to look at. We'll save that and we'll rerun it. And sure enough, we get readable plain text, and right down here we can see our flag, based AF for the win. We'll copy that, paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.